Let's continue with the next program called console.asm. Let's open it first in a text editor. We can see that this program, compared to bear.asm, is a bit longer. It contains more text. The first thing that we can recognize inside this program are the 4 instructions that we already had earlier inside the bear.asm program. Just for comparison, let's open bear.asm program 2. We can see that those 4 instructions are exactly those 4 instructions. Another thing that we can see is that the use32 directive is gone. It cannot be found inside console.asm. We are soon going to talk about it. Let's begin by explaining what we see inside this code. First, we have those 4 instructions, which we already know. And right after those 4 instructions, we have 2 more instructions, which we haven't seen before. The first one is push, and the next one is call. We also have a comment which explains those 2 instructions. It says exit the process. Basically, those 2 instructions actually exit the process. Whenever you invoke those instructions together, the program is going to end, at least on Windows operation system. You don't have to worry about knowing what those instructions are at this point. Just make sure to have those 2 instructions in the end of your program. In the future, you will have full understanding of how those instructions work. Next, we can see this, start and then a colon. What does that mean? Basically, it means that our program begins here, exactly here. This start and then a colon is something that we call a label. We are going to discuss labels in a more detailed fashion in the future, but for now just know that start is a label in your program. This start corresponds to this directive, entry start. This directive tells the assembler to search for the start label. This way the assembler knows that the program should begin from the start label. If I wanted, I could choose another name. For example, maybe start2. As long as I am being consistent, it is going to work. The next thing that I want to discuss is this line. Format PE console. This line is something that we are going to have in all the programs in this course. And it says that we want to create a file which is a console program. This is a very important line inside this source file. It directs the assembler to put the relevant information for the operation system. This way the operation system can understand which file is this, what kind of executable file is this, or what kind of program is this. If you omit this line, you will only get binary files, just like we got with bear.asm. This file is what allows you to create executable files with FASM. What does PE mean? PE stands for Portable Executable, which is the general format of executable files inside the Windows operation system. Every executable file that you see inside Windows is of this type, is of this format, the Portable Executable format. Regarding the last word here, console, there are other options. For example, GUI, Graphical User Interface. We are not going to discuss the other options to put here in this course. We are only going to deal with console program. What does console program mean? I remind you that the console or the command line is something that we have already seen. This is the console. Programs which are declared as console programs have the ability to communicate with the console. They can write things to the console or read things from the console. A different example is a Graphical User Interface program or GUI program. As an example, Calc is a Graphical User Interface program or a GUI program. As you can see, it is not inside the console. It has those buttons which we can click and this menu. Next, I want to discuss the sections. As you can see, we have those directives: section, text, code, readable, executable, and also section iData, import data readable. Whenever you declare a section, everything follows the declaration here is going to be inside this section. For example, all of this code is inside the text section. The next section is called the iData section, and all of those pieces of data are going to be inside the iData section. You might be wondering at this point, how can you know which sections to have inside your file? The sections that you have inside a portable executable file are pretty standard. You will usually have a text section where you will put your code. By the way, you could choose another name for this section. The name text is just a convention. Following the name of the section, we have the type, which is code, and then we have some properties. This text section, for example, has the properties of being readable and being executable. It means that the contents of this section could be read and also executed. And this is pretty important because we have code inside this section. We want to be able to execute this code. As opposed to the text section, the iData section has different properties. It is of type import and data, and it has the readable property. As an example, we will not be able to execute this section because it doesn't have the executable property. Sections usually have some meaningful purpose or some kind of definite purpose. As we said before, the text section will usually contain your code, and this is where your code will usually begin running from. The iData section, also known as the import section, has a different purpose. It is used to link our file into some other pieces of code. As an example, in this file, we want to have access to a piece of code called exit process, which resides inside the file kernel32.dll. Why would we want to have access to this piece of code? Because we don't want to write it again ourselves. Therefore, we use some ready-to-use libraries. Another reason is that some tasks cannot be done by a simple program. They can only be done by the operation system. And in those cases, we have to access some kind of interface that we get from the operation system. You can imagine it in this way. Our program is a very simple piece of code, as opposed to the operation system, which has full control over the system. The operation system has some kind of superpowers, and sometimes we need the operation system's help. In those cases, we can use the interface given to us to communicate with the operation system. In this example, in the end of the program, we communicate to the operation system that we want to exit the process. This piece of code, exit process, resides inside a file called kernel32.dll. This is a file that can be found in any Windows operation system these days, and it contains some other very important pieces of code. Let me show you where this file can be found, just to make sure that you understand that this is a real file. Here we can see the path C, Windows, System32. Let's look for this file. We can see that we find this file kernel32.dll inside the path C, Windows, System32. So there is such a file. It is a real file. I don't want to discuss at this point the structure of the iData section, or what is inside. This is some more advanced material, and it mostly relates to the operation system and not to assembly programming. We will touch those ideas in the end of the course. In addition, I also want to mention, just to make sure that we are on the same page here, that the sections, for example, are not things that the processor understands. The processor doesn't really care about sections, for example. It doesn't know about their existence. Sections are something that Windows understands, which means that it is more of a higher level idea. The processor only understands instructions. It doesn't care about file formats or sections or imports. These are just mechanisms that were built on top of the simple instructions. And those mechanisms are handled by the operation system. These are not mechanisms that you can find inside the processor. The processor only understands simple instructions. Next, I want to discuss this line, include win32a.inc. What this line actually do is taking the contents of a file called win32a.inc and pasting it exactly here instead of this line. There is nothing really special about this file. You could really include a file anywhere in your program. For example, if you wanted, you could write some piece of code with some instructions and then include it even here. Why do we need win32a.inc inside our program? This file gives us, for example, the syntax of section. This line is some kind of a macro. It defines some data structures, and the way that the data structures are defined can be found inside this file, win32a.inc. Basically, if we omit this line, the assembler will not know how to deal with those lines. And also with this line. In other words, this line or this file win32a.inc contains the syntax which allows us to use this section declaration and also this section declaration. Therefore, we need to include this file inside our program. Let me show you the location of win32a.inc, just so we can see that this is a real file. If we go to the path of the FASM-W, which is the location where you installed FASM, we can go to the include directory, which contains the file win32a.inc. This is the file which our program wants to include.